This is lesson 7.2b. We're going to continue talking about multiplying polynomials together. One of the methods that we're going to talk about today is the FOIL method. And the FOIL method is a shortcut for multiplying two binomials. So if you take a look at this, so it says to multiply two binomials using the FOIL method, you're going to find the sum of the products of, and see how it says FOIL down the side here, right? So the first terms, outside terms, inside terms, and last terms. And I have a little FOIL dance that I want you to do. It'll just kind of help you remember. So if you take your fingers, these are like the two binomials, right? So you've got your first terms. So they're the first things in those parentheses, right? So your first, outside, and then the inside terms, and then the last terms. So we started like this. We go first, outside, inside, last. Just a little reminder. It's kind of catchy. I like to do that to just kind of remind myself, okay, this is the direction that we're going. So we've got our first terms, our outside terms, inside, and our last terms. So we're going to take this idea and we're going to practice it with some examples. So if we see down here, for example, 1a, we have the binomials x minus 3 and x minus 6. So we're going to multiply these. Let's see, write these down. X minus 3 and then x minus 6. So the first terms in both of these binomials, the first ones are those x's. So I have, for this one, x times x. Then I go to my outside terms, right? And my outside terms are these two right here, so x and negative 6. So we've got negative 6 times x. Our inside terms, negative 3 and x. So negative 3 times x. And our last terms, negative 3 and negative 6. So I've got negative 3 times negative 6. So now that I have these things written out, now I'm going to simplify what I've got. So x times x is x squared. Negative 6 times x is negative 6x. Negative 3 times x is negative 3x. Negative 3 times negative 6 is positive 18. But just like we've talked about previously, we're going to look for like terms. So within this set, I have negative 6x and negative 3x that are like terms. So if I simplify, I've got x squared minus 9x plus 18, and this would be my simplified answer after multiplying those two binomials. So let's take a look at example B. We've got 2x plus 1 times 3x minus 5. So 2x plus 1 times 3x minus 5. I just realized I forgot to label this one as letter A. There we go. All right, so our first terms, first 2x times 3x. Outside terms, 2x times negative 5. Inside terms, we've got 1 times 3x. Notice the symbol in front of the 5. That's how I knew that it was going to be negative. And I used it to show the subtraction piece of it. That's why I've been writing that one first. And then my last terms are negative 5 times 1. All right, let's clean this up. 2 times 3 is 6. X times x is x squared, so 6x squared. Negative 5 times 2 is negative 10x. 1 times 3x is 3x, so plus 3x. Negative 5 times 1 is negative 5. Again, look for like terms. I've got negative 10x and positive 3x. So 6x squared minus 7x minus 5. All right, for example 2, we're going to be multiplying a binomial by a trinomial. We're going to do some of this using that area model that we did in the previous lesson. So if I take a look at this, I've got x plus 5, and then I have x squared minus 3x minus 2. So I'm going to write my first binomial here. And since when I made this table, I did the 2 on the side here. We're going to use these over here. So this is our x and our positive 5. And then since we have the trinomial, I wrote the 3 boxes on the top here. So each term is going to get its own box. Now remember, the sign in front determines whether it's a positive or negative number in the box. So x squared is positive. This 3x is negative. And this 2 is also negative. All right, now let's do our multiplying. So x times x squared. Remember, I keep the base and I add the exponent. So 1 plus 2 gives us 3x to the third. 5 times x squared is 5x squared. Negative 3x times x is negative 3x squared, right? Because I've got 2 x's there. 5 times negative 3x is negative 15x. There's no x on that one, so I just multiply those coefficients. Negative 2 times x is negative 2x. Negative 2 times positive 5 is negative 10. So now I'm going to take the information from my table and I'm going to write it out so that I can identify those things that are the same types of numbers. So I have x to the third minus 3x squared plus 5x squared. Now notice I just kind of was looking for things that were similar as I was writing them down. Minus 2x minus 15x minus 10. So now I go through and I look and say, okay, well, what are my like terms? Well, I've got negative 3x and negative 3x squared and positive 5x. I'm also noticing that I have negative 2x and negative 15x. So let's rewrite these. We've got x cubed, or to the third power, negative 3x squared plus 5x squared. Well, negative 3 plus 5 is negative 2x squared. Negative 2x minus 15x. Well, that's the same thing as having negative plus a negative. So negative 17x. And then that negative 10, he's just all by himself. So x cubed minus 2x squared minus 17x minus 10 would be our final answer for multiplying this binomial by a trinomial. And example 3. All right, here we go. Let's take a look at what we got in this problem. In a hockey, goalie behind the goal line can only, in hockey, a goalie behind the goal line can only play a puck in the trapezoidal region. So over here, this is a larger picture of what we've got right here. We are going to write a polynomial that represents the area of the trapezoidal region. And then we're going to find the area of the trapezoidal region when the shorter base is 22 feet. Wow, that seems like a lot. So let's start with part A. We are going to write a polynomial that represents the area of the trapezoidal region. Well, first of all, we need to know what is the formula for the area of a trapezoid. Well, that formula is 1/2 times the height times base 1 plus base 2. So now that we know our formula, we're going to go back and look at what information we have. So our height is always at a 90-degree angle. So let's just draw this line down here. So that height is x minus 11 feet. All right, so let's plug that in for our height, h. So that is x minus 11. 1/2 is just 1/2. That doesn't change because that's part of the formula to begin with. But then I have to do base 1 plus base 2. Okay, well, base 1, it doesn't matter which you call it, base 1 or base 2, because when we're adding, the order doesn't matter. So let's just call the top here base 1, and we'll call the bottom base 2. So let's label on here so we know which was which. So this was base 2. And this was base 1. All right, so base 1, according to this, is measured as just x plus base 2, which they've labeled x plus 6. All right, so we've got all the pieces that we need from our original equation. So let's go through and simplify what we can before we try to get our final polynomial. So we've got in here, x plus x is 2x plus that 6. Then we've got our x minus 11. That hasn't changed. And then this 1/2 that's still out here. So let's take a look. Remember, the order doesn't matter for multiplication. So what I'm going to do is I'm going to focus on these two binomials because I already know that I can use FOIL and I can figure out, I can simplify this. So the first terms are x times 2x. So x times 2x is 2x squared. Our outside terms, x times 6 is 6x. Our inside terms, whoops, I used the wrong color. Our inside terms, we've got negative 11 times 2x, so negative 22x. And our last terms, negative 11 times 6 is negative 66. Now, I'm going to clean this up just a little bit here. Let's rewrite what we have still. So we've got our 1/2 times 2x squared has no partner. 6x minus 22x gives us negative 16x. And negative 66 also has no partner. So now we have to use our distributive property. So half of 2x squared is 1x squared, or just x squared. 1/2 times negative 16x is negative 8x. And 1/2 times negative 66 is negative 33. So the polynomial that we are looking for part A is right there. Well, for part B, it says, find the area of the trapezoidal region when the shorter base is 22 feet. Well, let's take a look over here. Of our two bases, The shorter base is labeled just X. So if we're looking at trying to figure out what is the area of this region when the shorter base, or X, equals 22, that means that I have to take what I just created and I have to plug in 22 for X. So for part B, slide this up a bit. For part B, we're using the fact that X is equal to 22. So we've got 22 squared minus 8 times 22 minus 33. Now that we've plugged that in, we simply have to simplify. So 22 squared is 484 minus 8 times 22 is 176. And then we just have our minus 33. 484 minus 176 is 308. Subtract 33. So 308 minus 33 is 275. And since we're talking about area and it was in feet, then this would be 275 feet squared would be our label for that.